Long division, kids. I would love to say that this is going to be fun. You're probably not going to like it, but it's actually a pretty big skill. All right, so we're given f of x, it's 4x to the fourth plus 5x minus 4, and g of x is x squared minus 3x minus 2. We're supposed to find f of x divided by g of x. And we're going to do this through long division, which seems kind of funny, but it's doable. All right, so we're going to put 4x to the fourth inside. And I'm going to put in placeholders. I don't have any x cubes. I don't have any x squareds. Then plus 5x and then minus 4. And we're going to put the dividend, x squared minus 3x minus 2 on the outside. Or the divisor, sorry. This is the dividend, that's the divisor. Now, what I want to do is I want to multiply this x squared by something to become 4x to the fourth. So I'm going to need a 4, right? I'm also going to need an x squared. Because 4x squared times x squared is 4x to the fourth. And I'm going to use the distributive property from here on out. I'm going to distribute that to all three terms. I'm going to get 4x to the fourth minus 12x cubed minus 8x squared. Now you should always wrap before you subtract. You're more likely to make mistakes if you don't. Sorry about the squeaky squeaky. It is what it is. 4 take away 4 is nothing. 0 take away a negative, that's addition. No, my markers aren't working. It's going to be a positive 12x squared, cubed. 0, take away a negative, plus 8x squared. And just like you did in 4th and 5th grade, you bring things down. Because you're probably going to need that piece on the next line. The new goal is to take this x squared and become 12x cubed. And I know, and I hope that you know, that that takes a 12x. 12x times 12x times x squared is 12x cubed. 12x times negative 3 is minus 36x. 12x times negative 2 is minus 24x. And again, wrap before you subtract. Moving forward. This is 8 plus 36, which is 44. Did I make a mistake? That's supposed to be a square. 44x to the second. This is 5 plus 24 plus 29x. And yeah, there's another line. Now you've got to take this x squared and become 44, and that's going to take a 44 to do it. 44 times x squared is 44x squared. 44 times 3 is negative 132. Seems legit. Don't forget the x. And then 44 times negative 2 is minus 88. And I forgot to bring down some stuff here. I need that minus 4 there, don't I? Again, you wrap before you subtract. The 44x squareds cancel. 29 minus a negative 132x is going to be 161x, and it's positive. And then negative 4 minus a negative 88 is going to be positive 84. This, boys and girls, is your remainder. Because using positive exponents, you cannot multiply x squared by anything to become an x. So here is our quotient. Remember, this is called the quotient. We're going to add to it the remainder. The remainder is 161 pieces of x plus 84 pieces of the original divisor, x squared minus 3x minus 2. Good stuff. Good stuff. My wife is texting me. I'll be right back. All right, now I'm back. What else did I highlight? Nothing on that page. Looks like the next one I highlighted was number 6. Using long division, determine if x squared minus 1 is a factor of x cubed plus 4x squared minus x minus 4. Now you need to remember that factors and zeros are heavily related. So if I get a remainder of 0, then I have a factor. That's how it works, because I went in evenly with no remainder. It's kind of odd that we say that, but you say that you enter evenly because there's no remainder. All right, so I want to know if I'm going to enter x cubed plus 4x squared minus x minus 4, and I'm doing x squared minus 1. And this should work out. I remember making this problem. So to become x cubed, I'm going to need an x. Then I'm going to distribute, okay? That's going to give me x cubed minus x. Put like terms with like terms. Right before you subtract. X cubed minus x cubed is nothing. We're just going to drop that 4x squared right on through. And then a negative x take away a negative x is nothing because you're adding. And we'll bring this guy on down too, minus 4. Now we want this x squared to become 4x squared. And we're going to do that by multiplying by a positive 4. And that's going to give me, think about your distributive property, 4x squared minus 4. You wrap before you subtract, and you got 0 for a remainder. So the answer is yes, x squared minus 1 is a factor. Your quotient is the other factor. Now, what's it say to do? It says if yes, what is the other factor? So got it. Now completely factor it. So right now, if I took the original polynomial, it would factor as x squared minus 1 times x plus 4. But just like everything, it's like a bad infomercial. Wait, there's more. This piece factors. This is called a difference of two squares. It factors as x minus 1 times x plus 1. One of our goals is to get to complete factorization of any polynomial. And that is the complete factorization of that polynomial. Good stuff. It is if you like math. And you like factoring. But most of you do not like factoring. I don't know what to do about that. I don't know. Just learn how to factor. Your life will be a lot easier in math class. That's all I can tell you. Or sit there and resist and resist and resist. And maybe I'll get to teach you twice. Don't do that. Don't be that kid. You don't want to be a senior in Algebra 2. They almost never graduate. Now, the exception to that rule is a couple of kids, but the repeat kids who take the course twice, they hardly ever graduate. All right, so on number 8, we have function notation. You'll notice it says f of 10 is 0. That means that x equals 10 is a 0, which means the factor is x minus 10. So what we're going to do is we're going to do our long division with x minus 10. This is going to take a while too. Maybe. Let's see. Nope. Yeah, we're going to do a couple of steps on this one. First goal, take that x, make it 4x cubed. That's going to take a 4x squared. Notice how I line things up above the appropriate place? You don't have to do it, but what do I know? Then minus 40x squared. We're going to wrap before we subtract, right? That's what we do. If we don't wrap, we make mistakes. The x cubes cancel. A negative 30 plus a 40 is 10, so we have 10x squared. Bring down the negative 106x, and it'll get a little ugly from here on out. Not much I can do about that, but it will get a little ugly from here on out. Now I want to turn x into 10x squared. I'm going to do that by using a positive 10x. That's going to give me distributive property. 10x squared minus 100x. Hopefully by now you realize why the distributive property is such a big deal. We use it constantly. So a negative 106x, take away another negative 100x is just going to be negative 6x. And we're at our last move. And it's going to work out. We got that plus 60 we bring down. The new goal is to turn that x into a negative 6x. And you do that with a negative 6. So that's going to give me negative 6x plus 60. And if you wrap before you subtract, you're going to have your 0. So this is known, all right? I'm supposed to use that to factor it completely. So I have the original factor, which was x minus 10. Let's get this up here a little better. I'll do it down there. The original factor was x minus 10. This is also a factor, but wait, again, there's going to be more. It will factor 2. I'm a big fan of what's called guess and check. First, I'm also a big fan of pulling numbers out, too. When I look at 4, 10, and 6, I see that everything is divisible by a 2. That'll give me a 2x squared plus a 5x minus a 3. And that is a whole heck of a lot easier to factor. If you have a trinomial, you know you're going to have your double set of parentheses to create a 2x squared, takes a 2x and an x. Factors of 3 are going to be 3 and 1. Probably lined up something like that. Because the outside's going to make 6, the inside's going to make 1. So I need to be plus 6 minus 1. And that is how this piece factors. Now, mathematicians usually put whole numbers in the front. Remember we do y equals a. It's always a, and that happens to be the a value. So when we finish this thing, we're going to put the 2 out front. You got your x minus 10. The next one would probably be written x plus 3, and the last one 2x minus 1. And order's not a big deal. It's not, but that's the complete factorization of that thing. I like the stuff. I hope you do too. Trying to make that show up better for you. All right, the last one that I'm going to do. Actually, there's 2 more I was going to do. It looks like I've got time for it. I was going to do 9 and then the complete the square problem. That was my agenda. Nine's not a hard problem. A parabola has roots at x equals negative 3 and x equals 5. The point 1,8 exists on the parabola. Roots, by the way, are synonymous, whatever I'm trying to say here, with what we call x-intercepts and zeros. Okay, they mean the same exact thing. Write an equation of the parabola in standard form. To do that, you're going to use this intercept form, which I've given to you right here. A times x minus a root times x minus a root. And after plugging in the roots, use that point to plug in an x and a y value to find a. So let's start with this line right here. Of course, we'll just call it y. It makes it easier. If I do x minus a negative 3, I have x plus 3. If I do x minus 5, I'm still just x minus 5. Easy peasy lemon squeezy. That's line 1. Don't be the kid who plugs in everything at once. Line 2 is to take your point up here, which gives you an x and a y, and we have done this 100 times, and plug that in. So everywhere I see a y, I'm going to be an 8, and everywhere I see an x, I'm going to be a 1. And then you do this funny thing we call basic math. 1 plus 3 is 4. 1 minus 5 is negative 4. And by gosh, if you multiply a negative 4 and a positive 4 together, I feel quite positive that you get a negative 16. Next move would be to divide that negative 16 out. And I know when I don't show this work, it confuses kids, but I should not have to show you what 8 over negative 16 is. 8 divided by negative 16 is negative 1/2. It always has been, and it always will be. That goes there. That's going to give us y equals negative 1/2 of x plus 3 times x minus 5. Moving forward, I wanted it in standard form, so you got more work to do. You need to figure this out, right? I don't care if you FOIL or box. You do you, I'll do me. I'm going to FOIL this one. It's actually the double distributive property. X times x is x squared, minus 5x plus 3x is minus 2x, and then minus 15. But wait, you still got that negative 1/2 out front. It's called the distributive property, kids. You're going to distribute it to all 3 pieces. Negative 1/2 x squared, a negative times negative is positive. Half of 2 is an understood 1. Negative times a negative is positive, 15 over 2. Easy peasy lemon squeezy. And the last thing I'm going to do for y'all is this. Solve that thing by completing the square. You're still going to have to do the quadratic formula one. By the way, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. I really hope that thing's recording my voice because I seem to have the volume muted down here. I don't think that'll phase anything. We'll find out. Okie dokie. All right, first step in completing the square is either you move the constant to the other side or you divide all terms by a. I'm going to take this thing and I'm going to divide everything by 3. That's going to give me x squared minus 2x plus 4 equals 0. I'm going to take my 4 and I'm going to shift her to the right-hand side, and that's actually going to make her a negative number. Now I'm going to take half of b. b is negative 2. If I cut it in half, I get negative 1, which, by the way, tells me that this factors is x minus 1 times x minus 1. And I'm going to square that thing, and I'm going to add that to both sides. So look at x squared minus 2x plus 1 and decide for yourself, does it in fact factor as x minus 1 times x minus 1? Because yes, it does. The right-hand side adds to a negative 3. If something has been written twice, she has been squared at some point in her life. The opposite of a squaring operation would always be a square root operation. The root of negative 3 is not real, it is imaginary, and the square and the square root cancel each other out. Last move, add 1 to both sides, put it in front of the I. X is going to be 1 plus the imaginary root of 3, or 1 minus the imaginary root of 3. And I want you to remember that these are conjugates. One of them's plus I, one of them's minus I. They are conjugates of each other. And there you go, boys and girls. There is some of your homework from 3-4 long division. I hope you enjoyed.